All right, oh, sorry. This next lesson, we're going to be talking about everything about mixed numbers. It's going to be in two parts. First one, adding and subtracting, and the second one, how do we multiply and divide mixed numbers. Okay, so when it comes to adding and subtracting, there are two ways you can go about doing this. You can take, and I just kind of rewrite the numbers like vertically, so like 1 and 2/9 plus 3 and 4/9, and I take my fractions, and these both have like denominators, so we can just add them. If they didn't, we'd have to get like denominators, but since they're both 9, I'm going to do 4 plus 2, which is 6, so I have 6/9, and then 3 plus 1 is 4, so I'm ending up with 4 and 6/9, and then I reduce. So 3 goes into both of those, so I'm going to end up with 4 and 2/3. So that's one way. Now, the way that I prefer to do it, because then I don't have to remember, do I need to do it for this problem? Do I not? I just always make them improper fractions. So I'm going to do 9 times 1, which is 9. 9 plus 2 is 11. So I'm going to have 11/9 plus, and I'm going to do 9 plus 3 is, or plus 9 times 3 is 27. 27 plus 4 is 31. So we're going to have 31/9. So 11/9 plus 31/9. And then I'm going to take 11 plus 31, and I'm going to end up with 42/9. And then from there, I know that 3 divides into both of those. So I'm going to divide both by 3. 3 goes into 42, 14 times. Right, yep, there's 1, 12, yep. 14 times, and 3 goes into 9 3 times. So now I'm looking at 14/3, and then I'm going to do my 14 divided by 3. 3 goes in there 4 times. 3 times 4 is 12, leaving us with 2 as our remainder. So we end up with 4 and 2/3. Notice both of them get us there, and sometimes this is the faster route, and if it was an improper fraction, we would pull out that whole number and add it to our already there whole numbers. But I never have to think about that when I make them improper to begin with, and then change them into a mixed number. So like I said, it's an either or. When adding this method, either method works just fine. Now here we have different denominators, so we have to find that LCD. So our LCD for 6 and 8, I know that 6 is 24, can multiply to 24. I also know that 8 times 3 is 24. So we're going to go with 24 as our LCD. If you need to list them out to get to that LCD, that's fine. It is going to be easier for you the faster you can find that mentally. From there, like I said, I prefer to make my fractions into improper fractions and then make them like denominators. So I'm going to do 6 times 5, that's 30, and 30 plus 5 is 35. So we got 35/6 plus 8 times 3 is 24, and 24 plus 5 is 29. So then we got 29/8. All right, so now I got to make them into like denominators. So I'm going to take 35/6, and I'm going to take that numerator and denominator times 4. So that I end up with 35 times 4 is 140, and 6 times 4 is 24. So I have 140 over 24, and I know these are some pretty big numbers. And then I'm going to do 29/8 times 3, because 8 times 3 is 24, so that's going to give me my 24ths. And 29 times 3 is 87. So we have 87/24. That's our other one. And now that we are this same denominator, I am now going to take 140 plus 87, and I get 227 over 24. And as I was working this problem before, because I rarely do problems on the fly, I know 24 doesn't go into the first two, the 22, so that means I have to figure out, well, 24 times what gets me close to 227? So here are some tricks that I do. I start by going to my halfway point, the 5. I'm going to take 5 times 4 is 20. 5 times 2 is 10, plus 2 is 12. So I know that that gets me to 120, so I need to go quite a bit higher to get to the 200. So maybe I then try 8, right? And so then 8 times 4 is 32. 8 times 2 is 16, 17, 18, 19. Okay, so I'm closer to the 200. But notice when I do this guess and check, there is some thought process behind the numbers I choose. So I tried 5 because it let me know halfway whether I needed to be lower or higher. 8 is not enough, and 10 is more than what I'm needing. So what that means is 24 goes into 227 9 times. And so now I just needed what is 24 times 9. So 9 times 4 is 36. And 9 times 2 is 18, 19, 20, 21. So we're at 216. So now I'm going to do 227 minus 216 because basically this is what I'm in the middle of. Oops. Right? And I found that 9 went into it. And 227 minus 216 leaves us with, that's a 1 and that's a 1, 11. And so I end up with 9 and 11 24ths. And it may seem like, oh, Mrs. Cartwright, those were really big numbers. Like I said, you are more than welcome to add your whole numbers together and then do your fractions the way you need to do your fractions. It's just when I work with mixed numbers, I just make everything an improper fraction and work from there. All right, so now we're going to do a find the difference. We're going to try to make this a little faster. So they have the like denominators. So this is another reason I'm going to show you using the not changing improper, why I, especially with subtraction, like to change them to improper. So I'm going to start by doing 7 minus 5. So that's my whole number. I'm going to be left with 2. And then I'm going to do 1/3 minus 2/3. And 1/3 minus 2/3 is a negative 1/3. So now I have 2 minus 1/3. And so then I have to borrow from the 2, right, and make this a 1. And now I'm going to do 3/3 minus 1/3, and I'm left with 2/3. Okay, so that's one way of doing it. But if I were to make them improper, this never would have happened. So we got 21 22/3 minus 15 16 17/3. And so then 22 minus 17 leaves us with 5. So then I have 5/3. 3 goes into 5 once, leaving us with 2 remaining. So I end up with 1 2/3. So that's, again, this would be the main reason why I tend to just make everything improper, because then I never have to worry about borrowing from or adding to my whole number, because it just gets taken care of when we're using improper fractions. Last one, we have unlike denominators, so we have to find that lovely LCD. And so in this case with 9 and 6, our LCD is going to be 18. So I want to make those denominators 18. I'm going to do 9 times 9 is 81. 81 plus 2 is 83. So I have 83 ninths minus 8 times 6 is 48 plus 5 gives us 53. So 53 6. So now I'm going to take 83 ninths, take the numerator and the denominator times 2. So I will get 166 18ths. 166 18ths minus, and then I'm going to take 53 6. I'm going to take both of those times 3 because 6 times 3 is 18. And 53 times 3 is 159. So I have 156 minus 159 18ths and 166 minus 159. I'm going to borrow. 16 minus 9 is 7. That became a 5. So I am left with 7. So 7/18. And so that is what we're left with. And that's our answer. So again, yes, adding and subtracting, you get that choice. You could just subtract your whole numbers and then subtract your fractions. But if you're having to borrow, then that just becomes a whole nother issue. I highly suggest making a mixed number or making them improper fractions, doing the subtraction and then simplifying. Yes, they're big numbers, but you don't have to worry about messing up on the borrowing or carrying over. So until next time, we do have multiplying and dividing in the next video. So until then, peace.